the game. And please mute yourselves if you have a noisy background. Now, all the while we'll be looking at deterministic models. Management science reflects on certain information. So certain things are not certain. They are not deterministic. They are uncertain. They are probabilistic. They are stochastic. And that is why we need to look at stochastic nature of occurrences. Sometimes people look at probability and say, why do you study probability? Well, part of the reason why you study probability is because you want to make conclusion about population parameter. If you don't take probability, you make a very wrong conclusion. NDC will win the next election. MPP will need the next election without doing proper statistical testing. So you need to understand probability. You need to understand it. Okay. What is the probability that MPP or Democrats will win the next election? You got to know. Okay. That's why we look at probability. What is probability? Probability is simply the likelihood of an event happening. That's it. The long run relative frequency of an item. The likelihood of an event happening. Now, the likelihood of an event happening is what is known as probability. And the likelihood of the event happening is between 0 and 100%. The likelihood of the event happening plus the likelihood of the event not happening is 1. The likelihood of the event not happening is written as P E bar. And the likelihood of the event happening is PE. The two together will give you 1. Let's look at an event like this. Okay. Now, when you look at this event that you have on your screen, it talks about rolling a die. It's a multinomial situation because the size that you're going to have is a 1, 2, 3, or up to 6. What is the probability that the number 6 will happen if you roll a die? Who can tell us? What is the probability? What is the chance that 6 will appear? Quickly.
1 over 6.
1 over 6.
Okay. So you guys know that one. So that's cool. But let's look at relative probability. The dean has analyzed the records of 3,000 students who have gotten grades in management science in the past 4 years. They want to know the number of students who made A, F, and all so forth. This is your information. What is the probability that a student had an A? You can tell us. What is the probability that a student had an A?
Doc, Eugene here. The probability of students having a Eugene.
Yes.
So it will be a fraction of 300 divided by total number of students, which is the sum of the 300 plus 600 plus 1,005 plus 450 and then
up here.
Or 3,000.
Very good. So that's it. Now, what is the probability? That's what you just said. Okay. Who can give you an answer to this second one?
Doc, can we go back to the question?
Yes, we are back to the question.
Okay, so that one would be 150 over 3,000.
150 over 3,000. Okay, another marginal probability. Now, what is the probability that a student gets A or B, but not both? A or B, but not both. What law is it applying for that probability? A or B, but not both. Hey, that one is hard like that.
So it will be A union B into bracket minus A union intersection B.
Very good.
Into bracket.
So what would that be? A or B, but not both.
It will be, I think, 900 over 3,000.
No, you are not incorporating the minus intersection. It will be
Like, is there an
3,000.
intersection?
Yeah, but that's what he said, but not both.
Yeah, the intersection will be 0 since it's not possible to get both.
Okay. So A or B is going to be 10%, which is a 3 over 3,000, and then 600 over 3,000. So that will give you this. Okay, that is a A or B, but not both. Now, let's move on. Complement rule is when you have A complement, the probability of A complement is 1 minus the probability of A. The probability of A union B is the probability of AB. That's the one we just did. If there's no intersection, that's why A and B are disjoint or they are mutually exclusive. The probability of A union B, okay, but then minus the intersection is additive rule, which is probability of A, probability of B minus probability of A intersection. This is what we generally know, provided that they are joint event. If they are joint event, then you got to take out the joint, which is intersection. We're going to apply all of this to what we're about to do right now. A deck of cards. I want you to look at the deck of cards. Tell me the number of cards in the deck of cards.
52.
52. Very good. How many kings are in the deck of cards?
4.
How many queens?
4.
How many jacks?
4.
4 jacks.
Have a look at this for the next 10 seconds, because I'm going to ask you a lot of questions on it. Before you say that, go back and can you go back and let me see?
Mhm.
Okay, are you ready? Let's start. From a pack of well-shuffled cards, a card is picked at random. What is the probability that the selected card is a king or a queen? What is the probability that the card is a king or a queen? You can tell me. You all have the deck of cards in your head. What would be the probability that the card is a king or a queen? Hey, the PhD guys, you've done
That is
probability.
the answer is equal
4
to
over
I
52.
don't
1
need
over
an
13
answer. I
plus.
need the process to the answer.
That so is going
Raise
to
your
be
hand because we are having too macular behavior. Simon,
4 over 52.
I said I need a process. Let me see the next person.
You need a process as in how I arrived at that answer.
Jerry,
that. So a king or a queen is going to probability of a king or probability of a king, which is the same as probability of a king plus probability of queen. And so that's going to be 5 over 54 plus 5 over 54.
who is talking behind the thing like that? I think somebody is disturbing. Ben Susan, stop disturbing us. If you are not ready,
Hey, dog, please, it's
allow
not me.
those
I'm
who
not,
are ready.
it's not me.
Yes, Eugene.
Doc, please, I want to give it a try. So, the probability of a card being a queen or a king, the probability of it being a queen is 4 out of 52 cards, and that of the king is 4 out of 52. Since we have 4 kings and then 4 queens, so we'll have to sum the two probabilities, which is the sum of the 4 out of 52 plus the 4 out of the 52 for both the king and the queen, which is 8 out of 52, which will give us 2 out of 13, and that should be approximately 0.154. So in percentage terms, that should be like 15%.
Let's see.
That, but what I said, please, is it wrong?
I didn't hear what you said.
Okay. I said almost the same thing as.
So the one who just spoke, your final answer was what?
That is 0.15. That's the
In
probability.
fractional form, what was your final answer?
In fraction.
Emily, let's go to Emily.
Yeah,
Doc,
that's
2
what I
over
said. 2
10.
out of 13. Yeah.
All right. So that's 2 over 13 because of the all. Now let's go to the next one. What is the probability that the selected card is a king or a diamond? What is the probability that the selected card is a king or a diamond? How many kings are there?
Doc, we have 4 kings.
4.
How many diamonds?
Okay.
4
13.
diamonds.
13.
13
Hey, sorry, 13.
So you have 13 diamonds. This is a non-mutually exclusive event. Why is it non-mutually exclusive event?
Because some of the cards will be diamonds and king, a diamond and a king.
Yeah. Can you be a diamond and be a king at the same time?
Yes.
Yes.
Yeah. And so because you can be that, you need to take, because you are looking for the card is a king or a diamond. So you're looking at K union diamond or king union diamond, isn't it?
Yeah. Minus.
But then king union diamond doesn't mean that you should just find the probability of a king or plus the probability of a queen. You need to take out something. What do you take out?
The
The
intersection.
king diamond.
The intersection. Why?
We're thinking of them.
To prevent
avoid
double
duplication.
counting.
To prevent double counting. Why is the double counting?
Where they are kings and then diamond also.
Yes.
So that will be 4 over 52.
All kings are diamonds. All diamonds are kings. Which one is true?
Doc, none are true.
Neither of
None
them.
are true. Exactly. And so there is that intersection that you got to deal with. So the probability will be what? Finally. The probability of a king will be what?
Doc, 4 over 52.
And then for probability of a diamond.
13 over 52.
13 over 52.
Okay. And now we are talking about, what was the question? A king or a diamond?
Yeah.
So, and then the probability of a king, what do you call it? A king and a diamond.
It's 1 over 52.
1
No,
over
the final
52.
answer is 1 over 4.
No, it can't be 1 over 4.
No, it's 4 over
4
13.
over 13.
4 over 13.
Okay.
So master these ingredients. Okay. So these are your answers to be 4 over 13. This is it. Guys, these are the basics of probability. We haven't reached anywhere. Let's move on. Okay. Let's look at independence. Multiplication in probability. Okay. There's a rule there for independence. Suppose you have an event A and event B, and these are independent of each other. The probability of A given B is equal to the probability of A. So that the probability of A intersection B will be probability of A, probability of B. Now, why is that so? Because the probability of A given B equals the probability of A, because they are independent. If that is the case, then the intersection will be both probability of A and probability of B. This rule is an independence rule. Process that before we continue. Let's take an example. The probability that you will get A in statistics is 70%. The probability that you'll get A in machine learning is 50%. Assuming these two events are independent, what is the probability that you get A in both? Who can tell us? What is the
No,
probability?
the answer will be 0.35.
I need fractions. It's easy to cancel.
7 over 20.
Sorry, 1 second. Alex, do you understand?
Yes.
Yes, Doc.
Looks like I'm having a different slide. Okay, do you understand? It's correct.
Yes, Doc.
All right. So you find the probability of this, probability of that, just multiply the two. Okay. I don't know what she said, but when you find the
It
probability,
says 7.2.
7.2.
No,
7 over
7 over
20.
20
Okay.
or 0.35.
Yeah. So that's it. Now let's look at, so that one was independent. Let's look at the situation of dependence or conditional. Probability of A intersection B is a probability of A multiplied by probability of A giving B. This is conditional because the second one, probability of A giving B, that is conditional. Now, let's take another example. These are not my main thing for today, so I'll move it slightly faster. Two cards are drawn in succession, after one after the other. After every draw, the selected card is not replaced. So whatever is going to happen is going to be conditioned on the fact that this one wasn't replaced. What is the probability that in both draws, two draws, you will get spade? What is the probability that in both draws, you will get spade? So the first draw, what did you get? A spade is drawn, isn't it?
Yes,
Yes, Doc.
Then the second draw, what was also drawn? A spade.
a spade.
So the first draw will be what? How many spades are there?
13. So
13.
13 over 52.
So you get 13 over 52. The second one, so the first one is going to be the probability of spade, isn't it?
Yes.
Yes, Doc.
But the second one is going to be the probability of a spade, given that there has been a first draw.
Yes.
So what will be
Yes,
the
Doc.
probability there?
12 over
12
51.
over 51.
12 over 51, because we are dealing with that replacement. Solo, are you here? I know it when some of you are lost.
I'm here. I'm here.
All right. Ask questions. So now what we are looking for is what is the probability that both draws? What is the probability that in both draws you get a spade? What will you do to the two?
Multiply.
Dog, you multiply.
Multiply, you don't add. Okay. When you do that, you're going to get something like 117.
1 over 17, yes.
Who is not clear? Now, we'll be looking at conditional probability and Bayes theorem. Okay. Those particular types of conditional probability and Bayes are things that you should learn on your own. But then my interesting part today is the types of random variables, okay, which are drawn from probability theory. What is a random variable? A random variable is defined based on whether it's a discrete or continuous. It's a variable that has the chance of occurring in any series. It can be discrete, it can be continuous. What is the difference between a discrete random variable and a continuous random variable? By the way, in case you all don't know, the random variable is given by the letter X. Capital. Simon, what is the difference between random variable that is discrete and one that is continuous? Simple, Ray.
So the one that is discrete, you have only two options, whether it happens or not. And the one that's continuous, there are many options, more than two.
And he said the one that is discrete is what?
Has only two options.
No.
But whether this happens or the other happens.
No. Simon. Kojo?
Doc,
Go ahead. What's the difference?
so the discrete, as I said earlier on,
You were the one who spoke earlier.
yeah, the
Okay.
next is Solomon.
Solomon.
Yes, discrete values are those ones that you can count, the countable ones,
Mm-hmm.
and then the continuous are the one you can pick in a range.
Give me an example.
Maybe okay, the discrete is like goals scored in a match, for instance, and then the continuous is maybe taking the height of a certain group of people
Very good. Very good.
or weights, for instance.
Excellent. So you can see that because the discrete account, you have them, even in their distribution is but a continuous is a smooth curve because there are multiple possibilities. How you define each one of them is in the format that you're seeing here. Now, the probability distribution of any random variable can be described, and the description will tell you how probabilities are distributed over the values of that random variable. This is how we write it. The probability of a particular random variable X is equal to its description. Now, its description can be a numerical value or a range of numerical values. Its description is numerical values or a range of its numerical values. Now, there are a lot of many types of data. Because of that, many different ways are there for us to collect a sample data. And so we need lots of different probability models to do that. So if I'm going to collect this particular sample data, I need the distribution. And hence I need a probability model. One particular probability distribution that is common is binomial distribution. It is that kind of model that will turn out to be very useful in many practical settings. So I want to start by looking at binomial probability. Binomial probability begins with understanding a Bernoulli trial. Now, this question will go to the PhD student. The PhD student, are you here? What is the difference between a binomial distribution and a Bernoulli trial? Jerry, Emily, and then Solomon, Albert.
Look, I remember for Bernoulli, there's only one trial, whilst for binomial, you can do multiple trials.
Very good. Guys, in case you don't know, that's a real answer. So Bernoulli trial is a single experiment. A single experiment. Of course, it has two possibilities. Okay. That is a Bernoulli trial. But the binomial tells you the number of successes in an independent Bernoulli trials. So the binomial distribution captures independent Bernoulli trials. What's his name? Eugene, do you understand? Do you understand, Eugene?
Doc, please, you have to explain it again, no? Because
why? But you didn't ask me, you didn't tell me that you don't understand for me to explain it again. Follow me. When you ask, then I know that you really, really want to understand.
Okay, Doc.
It's not like, will you eat before you say, I'm hungry? Will you eat before you say, I'm hungry? All right. Now, the probability of success in a binomial situation is represented by P. And this probability of success doesn't change. Okay, it is constant. If you toss a coin, the probability of success, if you want a head and the probability of success is a head, it doesn't change. Another characteristic of a binomial distribution is that the trials don't depend on each other. And you want to model the number of successes within the trials. We've already said the probability of success is P. The probability of failure is 1 minus P. So there are a lot of examples of binomial. I just gave an example of head or tail when you are tossing a coin? Who can give me another example of binomial situations? Raise your hand and give me one. Everybody give me one. If somebody says your own, think of another. Albert.
So the gender of a child could be male or female.
Gender of a child. Next.
Doc, please. Sorry, I didn't get the question.
Sorry?
Okay, Doc, mine is passing or failing an exams.
Okay. Emily, lower your hand so that I see the next person. Albert, lower your hand. You said your own. Next.
The question. So I didn't hear it.
Lower your what is it? Mute your this thing if you are not talking. Simon.
It's either day or night.
What about dawn?
Dawn is part of night.
Okay. Next.
Good or bad?
What about ugly? People are giving very, very cheap ones. And that's how I see you're looking at. You're looking more at the easy peasy ones. Easy peasy ones. You don't want to kind of struggle. Yes, Simon. Hey, so the rest, you don't know what you want.
Doc, light switch on and off.
Okay, on and off, light switch. Emily.
Doc, good or defective? Like perfect or defective?
Hey. That is perfect or defective. Defective
Like if you're looking
or
at
non-defective.
Not non-defective.
okay.
All right. So these are some of the examples that you have here. Okay, please take notes. The most important thing in this part of the course is for you to be able to identify a question that is binomial and a question that is Poisson and a question that is normal. Tell the differences. And to do that, you need to know the binomial formula. It's called a probability distribution function of a binomial formula. This is a probability distribution function. Please, everybody write it. This is a probability distribution function of a binomial distribution. After writing it, just say done. So I know.
Done.
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 Okay, waiting for the rest.
Done.
Done, Doc.
Okay. So what is the N? What do you think the N stands for? Anybody?
N factorial.
I didn't say N factorial. I said, what is the N? Raise your hand. You see, people don't raise their hands. They are the ones who make mistakes. Albert.
The number of trials.
The number of trials, also called what?
The events.
No. The number of trials, also known as what?
The number of vectors. I don't remember it as trials.
Albert. It's also the sample size. What does the P mean and what is the 1 minus P? The P is the probability of success, the 1 minus P is the probability of failure, the N factorial is N exclamation. Factorial is an exclamation mark. 0 factorial is always equal to 1. What is 2 factorial? No PhD student should tell me. What is 2 factorial?
The
No PhD
2
student should answer.
factorial is 2 times 1.
Oh,
It's like she doesn't hear, Paul. Should I mute people so that people will be forced to raise their hands?
Look, I thought you said PhD student should answer.
Your ear are moving too fast. I said the opposite. Yeah. What is 4 factorial? Solomon.
4 factorial is 4 times 3 times 2 times 1. Let me just
Solomon.
calculate.
Okay, good. Simon, what is
4
3
times
factorial?
3 times 2 times 1.
All right. So now that you've all written the formula, this is also the mean and the variance of binomial function. The mean is NP, and then the variance is that same NP multiplied by 1 minus P. Write it down. Write it down. Write it down. Okay. So now let's take a question. Let's also quickly do Poisson before we now combine the two. A Poisson distribution or a Poisson random normally distributed, a random variable that is Poisson distributed, okay, is useful to estimate the number of events over a specified period of time. See, the thing about binomial and versus random Poisson is that Poisson looks at the average or the mean of something over a time, over a space, over an area, or over an interval. So Poisson looks at the average of the items during the interval, or within the interval, or within the time, or within the space. Poisson looks at the mean. Binomial looks at the exact. Both are discrete. Poisson looks at the mean, binomial looks at the exact. Both are discrete. Poisson is a limiting case of the binomial distribution. That is Poisson. So if we are talking about the mean of an event, that's Poisson for you. But if you are talking about the probability, the exact probability of an event, that's binomial for you. The characteristics of the Poisson is that it deals with the average or the mean of the occurrence. Not just the occurrence, but its mean. Take, for example, tell me which one of the things on your screen is binomial and which one is Poisson. Carefully tell me. Number one, who can tell me whether it's binomial or Poisson? Quickly. Watch the way.
Doc, I think to prevent confusion, you should call us so that we don't.
Yeah, I was going to even say, I was going to say that I'm going to use your names alphabetically to call you. So let me start with Albert. First one.
Yeah, it's Poisson.
Why?
Because of the time interval on a shot within an hour.
Okay, now the second one, Simon.
Goal score in a football match. It is binomial.
That's wrong. And this one is not passed over because if it's not Poisson, it's that. Who can tell me why it's binomial? So you're wrong. Why is this Poisson instead of binomial?
No, because it doesn't have just 2 outcomes. They can score as many as they want.
Yeah, but why is it Poisson? Albert.
Because a football match has a defined time,
Which is
90 minutes.
next time be specific. You don't let me ask you which is.
Yes, Doc.
So there's an interval, a time interval. That's key. And that is what.
So it is not about the specific number of goals.
No, it's irrelevant. It's when that specific number of goals is happening. It's happening within the hour, or within 90 minutes, within a time space, within a space phrase, within a certain specific length or area or time. Next person. And that goes to Jerry.
Yes, Doc.
Shoot.
That one was on.
Why?
Because the per meter square of a glass panel may have intervals, may have a range. It may not be exact. It's a continuous variable.
Very good. Simon, next one.
Is this Solomon or Simon? Doc.
Solomon, sorry.
Yeah.
Oh, you done it
binomial.
already?
No. Binomial.
Right.
The answer is binomial.
Why?
Because it's either more functional or functioning. So two outcomes.
That's wrong. The most difficult thing is you not being able to identify whether it's binomial. It is per day. The fact that you have been given the thing happening per day makes it Poisson. It's never binomial. It's malfunction, of course, but malfunction within a specified period, and the period is per day. Next one. That goes to Eugene.
No, this is Poisson because there can be multiple flaws on the cable, on the cable's length.
Multiple flaws on the cable's length. No, that is not the explanation. That's not the explanation.
So then let me try again.
Yeah.
The event or the flaws, which is the event, can occur over a certain length.
Okay.
Yes.
So it's not, who can tell? Who can tell? It's not a multiple flaws on a cable length, but who can tell why this is Poisson?
Because the length has a range.
Yes, because there's a range, there's a gap, there's an interval for the cable. Getting or not getting a bid in for a contract. Jerry.
Dog, it's binomial.
All right, okay. Now, this is also the Poisson formula. Write it down. The Poisson formula is given by the probability of X is equal to e raised to the power lambda, lambda raised to the power X over X factorial. The lambda is the mean of the event. The X is the number of successes. And normally, that is it for forever. Write the formula for the Poisson. This is the probability density function for Poisson. Of course, if it is a cumulative probability density function, the way you write it is slightly different. Or you will calculate individual probability density function, then you will add them yourself. That gives the cumulative. Okay, next, let's move on. The mean and the variance of a Poisson are the same. That is the lambda, the average. So the average makes the mean and then the variance. All right. So now that you write this down to the mean and the variance. So we're going to take a couple of questions to see how you identify. So let's take the first one. Please, you will never know that is Poisson or binomial directly. So I'll always ask you, what is the probability of one success in 5 observations if the probability of success is 0.1? Is this binomial or Poisson? This one is too obvious. This one, you raise your hand. Have it.
Look, it's binomial.
Why?
One, there's no time or space interval, and there's either success or failure.
That's it. You can either have success or failure, and this was specifically written. So now all of you find it. You have the binomial formula. Find the question. What is the probability of one success in 5 observations if the probability of success is 0.1? Who is that? Okay. Who has the answer? So first of all, you got to identify the element. The element, and once you identify the binomial, find your n, find your p, find your 1 minus p. What is n? What is the sample size here?
The
5.
number of, yeah, 5.
What is it?
5 observations.
5. So the sample size is 5. What is p?
0.1.
0.1. What is 1 minus p?
0.9. 0.9.
0.9. Very good. So you're going to substitute all this and do your calculation. So you substitute this into the formula. What do you get?
0.32.
Excellent. 32.8%. That is the value you get. This is it. If you are not clear, you say it. Next one. Because example is more efficacious than precept. What is the probability of getting exactly 2 tails in 3 tosses of a coin? First, is this binomial or Poisson? What is the probability of getting exactly 2 tails in 3 tosses of a coin? Is this binomial or Poisson? What is your comment? Whether it's binomial or Poisson?
That is binomial. Okay.
Okay. Why? Which word? Which word? What makes it binomial?
What should I continue?
Continue.
Okay, so we are looking at the probability of success or failure, and we also have a finite number of trials.
How do you know that you are looking at probability of success or failure?
Okay, so we are looking at probability of getting exactly 2 tails in 3 tosses.
So what is the success here?
So getting a tail is a success.
That's it. Getting a tail is a success, and then getting a head is a failure. Good. So now that we know it's binomial, what is n? What is p? What is 1 minus p? And then x. What is n?
Doc, N is 3.
What is p?
P is 2.
No.
I'm sorry, P is 0.5.
P is 0.5 because it's a probability of toss up a coin. What is 1 minus p?
0.5.
What is x?
2.
Very good. So guys, substitute all this into the formula and tell me your answer. We are talking about probability of exactly 2. Substitute and tell me your answer.
I had 0.375, which is 3 out of 8.
That's your final answer.
Yes, please.
Very good. That's fine. 0.375. Are you all clear with that?
Yes.
Yuji, you were the one who gave the answer.
Yes, Doc.
Very good. That's excellent work. Now, next one. Samsung Ghana gives a 2-year warranty on the phones it makes. From past experience, it knows that 0.5% of its phones will be faulty and fail within the warranty period. What is the probability that out of a consignment of 500 phones, none will be faulty? More than 3 are faulty. Is this binomial or Poisson? And why? Albert.
Doc, I believe it's Poisson because of the 2-year warranty.
Excellent. You've never seen this question before, have you?
No.
Exactly. So it means that all the probability distributions you've done, you have a clear indication of what Poisson is. And this is sharpening your mind with your PhD work as well. Okay. Because this must be seen by each one of you as an exam question. Now, do you understand, Solomon?
Yes, I do.
Okay. Solve it, everybody. Okay. If you are to solve, okay, now that you know it's Poisson, what are the elements of the Poisson you need? In Poisson formula, what are the things you need? Albert.
Lambda and x.
Lambda and x. So the question now becomes, what is your lambda here?
0.5%.
Okay, find your value of lambda. Let me see. What is your value of lambda? Everybody. You have to think. You don't just pick the answer. Who has found the value of lambda first?
Doc, please, let me give it a try.
Okay.
So, since Samsung is saying 0.5% of its phones are faulty and will fail over the period, and we know the total number of phones, which is 500, I to get the lambda, I multiply the 500 by the 5%, which is 0.005, and I got 2.5 for the lambda.
2.5. That's your final
Yeah.
answer.
Yes, please. That's what I got. I believe so. Yes.
It is correct. Guys, do you understand why 2.5 is the average or the lambda? Who doesn't understand? If you don't understand, you let us know. Otherwise, yes. We are talking about 0.5%, 0.5% of the consignment, which is 500. That is how come. And that will give you 2.5. Now use that to find the probability that none will be faulty. What to be the probability that none of them will be faulty? All of you work it. Yes, Emily.
Doc, the answer will be 0.082.
0.082. That is correct. Because when you substitute this into the formula here, you're going to get 0.082. Once you know the lambda, the rest is 0, which is an x. Now let's go to the next one. What is the probability that more than 3 are faulty? More than 3. Probability that x is greater than 3. More than 3. How do you go about it? More than 340, remember there are 500. You can't move all the way to 500. So instead of going more than 3, you do 1 minus the probability of 0 to 1. Do you get it? Emily?
Doc, so 1 minus probability of 0 to 3.
What do you get?
Okay, so we already know P of 0, which is
What's your final
0.08.
answer first?
Okay.
Because I'm showing the final result.
I'm now adding them up. Okay.
So you will have to now take the probability of 0, probability of 1. Okay, find the probability of x is 0, x is 1, x is 2, and then x is 3, because the question was on more than 3. So if it is on more than 3, then you have to look at 3 or less.
Yeah.
And once you find all of them, you subtract each one of them from the 3, okay, as you can see here. And that will be 24%. Simon, do you get it?
No, Doc.
Emily, explain to him.
Okay, so the question was asking for probability that x was greater than 3. So since the x can go up to 500, if you want to go that way, you have to do probability of 3 and add all up to that 500, which will be impossible to do. So rather, we'll find the opposite of it and then subtract from 1. And so the opposite of x greater than 3 is x less than or equal to 3. And that's what we use. So if x is less than or equal to 3, then we are talking about x being 0, being 1, being 2, and then being 3. So we find the probability of these numbers. So 0, 1, 2, and 3. And then we add them together and subtract from 1. Are you okay now?
Yeah, can we scroll down? Doc, can you scroll down? Let me check something.
There's nothing down.
So the probability of x,
Remember, we already did for the 0. That's why it's not showing here.
I get it. So what it means is that, no, I'm not getting it, because, so what's the result for probability that x is equal to 0?
So the result was what we did previously.
It was this.
Remember when we did
X equals to 0. We did that first.
that's what the A part.
0.082. You have to do probability that x equals to 0. And wherever you see x in the formula, give it the 0. And we already know the lambda, 2.5.
Yes.
Does it make sense now?
I'm still confused.
You are confused about how she got this? How she got this first one?
Yes. That's where my problem is.
Emily, take your time and explain this. Let me see.
Okay, so we are looking for the probability that x is equal to 0. And the formula for Poisson, you can see that is e raised to the power, the negative lambda, then lambda raised to the power x all over x factorial. And so all we did was the values of lambda and x that we had, which is up here. So our lambda was 2.5 and x here, at this stage, we were looking at the probability of there being no defective. So we were looking at x being 0. So we had our x to be 0 and the lambda to be 2.5. And all we did was just put them into the formula. So wherever we see lambda, we put the 2.5. And then wherever we see x, we put the 0. And that's what gave us the answer.
Okay. I'm okay with that.
Okay.
You are sorted. Very good. Anybody else? And once you use that approach to find the 0, you can find the rest of the 1 to 3. And then you can add them. So you can see that the 0 comes first here. Then the 1 is here. The 2 is here. The 3 is there. All of them subtracted from probability of 1. I mean 1. That will give you the probability that more than 3 forms. So one thing about the probability is that if you can't move all the way from 3 to 500, you can use 1 minus the probability of 0 to 3. Do you get it?
Yes, Doc.
All right, okay. So that is how you execute all of this. Let's look at the next one. Bob is concerned about the low retention rate for employees. In recent years, management has seen a turnover of 10% of the hourly employees annually. Therefore, management, for any hourly employee chosen at random, management estimates a probability of 10% that the person will not be with the company next year. Choosing 3 hourly employees at random, what is the probability that one of them will leave the company this year? Find the mean and the standard deviation and the variance. Is this binomial or Poisson? Is this binomial or Poisson? Anybody? Let's address that first.
Doc Poisson.
Albert.
Doc Poisson, because of the time period vesting within the year.
That's wrong. It's binomial. The ability to tell whether it's binomial or Poisson is the most important thing in the work. Management has seen a turnover of 10% of the hourly employee annually, 10% of the employees. You cannot use what your feelings are. It should be based on facts. Look at it. It says management estimates a probability of 0.1% or 0.1, 10%, that the person will not be with the company. So there are 2 outcomes. What are the outcomes?
Either they are with the company or they are not with the company.
So what is Poisson about that?
Now, the sentence continues to say with the company next year, making
year.
it seem as if it's fixed period.
Yeah.
No. So because once you identify that this is Poisson, the next thing is that you have to identify what is the mean.
There's no population. I mean, there's no large.
And there's no way you calculate the mean from anything.
Yeah. Okay, then that's another great way to also tell.
Oh yeah, there are several ways you have to use to be able to tell. But then you know that the binomial has got 4 elements. So in this case, what is n?
3.
What's the sample size?
3 people, 3 employees.
What is the p?
10%.
What is the
P
1
should be
minus
0.1.
P is 0.1.
Yes.
What is 1 minus p?
0.9.
What is x?
X in this case is 1.
This is 1. So this is it. So once you have all these elements, you substitute it and you get 24.3%. Finding the thing as binomial or Poisson is key.
Doc, can you please go back to the question?
Yeah.
Okay, thank you. I'm okay.
Next. You were told to also find the expected value and the variance. Find that. You wrote the formula for Poisson binomial. It's expected value Do you remember the expected value
Yes, Doc.
and the variance? Find that in term.
Okay, so expected value is 0.3.
And variance.
Variance is 0.27.
That is correct in both ways. So this is expected value and that of the variance. Any question? This was self-explanatory. The most important thing is knowing that it's binomial or Poisson. That's it. That's the most important thing. But let's look at this. Be careful here. It's also tricky. In a typical month, an insurance agent presents life insurance plans to 40 customers. Historically, 1 in 4 customers chooses to buy life insurance from this agent. Based on the relevant information, answer the following. Is this binomial or Poisson?
Doc, this one is clearly Poisson.
Are you sure?
I won't agree. I won't agree if it's binomial.
Me too.
Okay. There is a course known as a topic known as the Poisson approximation to normal distribution or by Poisson approximation to binomial distribution. This is not Poisson. This is binomial. Solomon, are you here? You are dead, eh? Don't die.
I'm very much alive.
Okay. Simon, are you here?
I'm here.
You see, when I tell you that it's binomial, that's when you begin to think. That is when you begin to think and you begin to now say, okay, I understand. In a binomial distribution, there are 2 outcomes, success and failure. There are 2 choices. There were 2 outcomes, 2 choices. Was there a statement that helps you to know that you got to make a choice?
Yes, there is.
Yeah,
What's the statement?
customers chooses to buy life insurance.
Yes. So which means customers can also choose not to work.
Hey, look, this thing is too confusing.
You use the word typical month, right? To determine,
They said,
you use the typical month to determine the length. What motivated you to think is Poisson?
okay, so for the Poisson, we need just the lambda.
Of course, but what is here that gives you a lambda mind?
Okay, Doc, one reason why I thought it was Poisson was because there's nothing, I'm not seeing anything from this statement that's giving the probability of success or failure.
Is there 1 in 4? If it was actually numbers, you would have seen clearly.
So 0.25.
1 in 4. How do you write 1?
Okay.
He said historically 1 in 4 chooses to buy.
So success is 0.25.
1 in 4. What is that? Yes.
1 over 4.
1 over 4.
Yeah, so use that to 1 over 4 easily. Of course, it's 0.25, I know, but I'm saying that use that 1 over 4 so that it helps you to know that that is where your probability is coming from. The choices are indicative also of binomial. How would you have found your destiny, your average, if you were to use Poisson? There's a way you can use Poisson if you were to force it to become to find the average.
Yeah, but the same 1/4 multiplying the number of customers.
That 1/4 never didn't
Yeah.
come into your mind before.
No, that's
That's how I would have found the lambda.
exactly.
Yeah, but that 1/4 didn't come into your mind that it
For
was.
for binomial, no, it didn't go there.
You said that what made you think it was lambda was what? It was Poisson was what?
Though I was going to use the 1/4 multiplying the number of customers to get the lambda.
Yeah, but what gave you the impression it was Poisson? That's my question.
Look, because I was getting the lambda that way. So as long as I got the lambda, then I could use Poisson to solve it.
No.
Yeah.
Everything put together. Always ask yourself, why is it not binomial or why is it not Poisson?
Okay.
So first of all, you can't use the lambda alone. In fact, it's the last resort. I thought you were going to use a typical month, actually. Then I'll tell you that, but then this typical month, the exact thing was not shown. So the exact value was not given. And so you can't specifically use that number. Typical month can be 28. Typical month can be 30. Typical month can be 31. Two of us.
Yes, Doc.
Okay. What is now the probability that exactly 5 will buy? Well, you just substitute 5 for the x, like this. And that will give you a clear answer of 2.7%. Does that make sense? Next one. What is the probability that no more than 10 will buy? So this is where you have to use your knowledge of 1 minus 2, things like that. Okay, what's the probability of no more than 10? No more than 10 will mean that you are calculating the probability of 10 or less, isn't it? No more than 10.
Yes.
So that means you need to find probability of 0 to probability of 10. Oh, yeah. We did it. We always try to find it, and we did do it. This is it. We find a probability of 0, find probability of 1, find probability of 2, and it continues here up to 10.
But this one, the opposites can't come in. That one is even more tedious.
Exactly. You can use the opposite. Now let's go back to the next one. What is the probability that at least 20 customers will buy the life insurance? That is worse. At least 20 means 20 or more. The sample size is what? 40. Determine the mean and the standard deviation of the number of customers who will buy from this agent. So this is the mean and then the variance or standard deviation. So the one for the 20, this is it. This is how you worked it. The mean is NP. So that is 40 times the P, which is 25%. Then the variance or the standard deviation is NP into bracket 1 minus P all to the power of the square root. You substitute and you eventually get 2.739. So that is how you undertake this particular one. Let's look at the next one. We won't solve this. We'll just find out. Is this binomial or Poisson? Is this binomial or Poisson? Looking at this, is it binomial or Poisson? Now you are confused. You are being careful. Amy.
I think
Doc,
it's binomial.
Doc, I'm still reading.
I think it's binomial.
Justify.
But he said,
Explain.
okay, so this one looks more of exact. So, for example, given that 10%, 20% of them are defective, it looks more of exact than range or given an interval.
Okay. It doesn't make so sense to me.
Doc, let me try.
Try.
Yeah, because there's the option to test for defects, then there will be the probability that there are no defects. So it's binomial.
Good.
The outcomes are
Binomial
two.
because we have defective and then non-defective labels or batches. It's because it can be defective or non-defective. That's one. Second, two, we have 20% of all batches. So you're able to get a probability of defective batches, which is probability of success. Okay. So this is a pure binomial. Exactly 2 means x is equal to 2. So you substitute that and find that x is equal to 2. Your probability of success is 2%. Your probability of failure is n is 4. So you write this into the binomial formula and you will get 15.3%. Do you all get it? If you don't understand, let me know. Next, the other one is 2 or more. So you have to just deduce by for example, it says if 2 or more. So 2 or more, the total is 4. So if you're looking for 2 or more, it is 2, 3, and 4. Or if you want to go backward, it's 1 minus 0 and 1. 1 minus 0 and 1. Okay. So you can do 2, 3, 4 like this one. Okay. Or you can do 1 minus 0 and 1. So you have 1 minus less than or equal to 0, 1. Either of them will give you the same answer. And that will be 18%. Are you clear? Are you clear?
Yes, Doc.
All right. Then the last one is find the probability of less defectives. Less than 2. Less than 2. Less than 2 means that you do 0 and 1. So you find that of 0, find that of 1, you substitute, and hooray! All right. So that is it. In fact, at this stage, I'm just going to pause for us to continue next time on the normal distribution. Okay, these are the 2 main things that you need to know about binomial and Poisson. Okay, binomial and Poisson. The most important thing is identify that within the Poisson, you are dealing with the mean of the probability. But binomial, you must read the thing well to give you a sense of choice. That's it. There is a sense of selecting. And then in addition, you'll be able to identify the sample size, the probability, and then the random variable. The sample size, the probability, and that particular random choice that you are dealing with. That's it. Any question?